Okay, question one. Elizabeth plans on buying a new car for $25,000. The model she is looking at depreciates at a rate of 8.5% per year. Elizabeth plans on keeping the car for 2 years or as long as it is worth more than $15,000. They want us to create an inequality, so we know we're going to have a less than or greater than symbol. And in fact, they tell us right here what that symbol is going to look like. That represents the amount of time Elizabeth will own the car and then use it to answer the question. So these are the two main formulas you need for problems like this. We have, of course, the growth formula and the decay formula. Specifically, we'll use the decay formula because they use the word depreciate. Depreciate and decay are synonyms. So let's get rid of the growth formula and just focus on the decay formula. A couple of changes we want to make, though. In this question, the equation, it's not an equal to, it's not an equation, it's an inequality. So this inequality, it needs to be greater than y. So I'm going to put the y on the right-hand side instead of putting y equal to. Next thing I'm going to do is I'm going to label what each one of these variables represents. R is just the percentage divided by 100. A is going to be our initial value. And then X, not always, but X is the time variable. Typically in these exponential problems, X ends up representing some unit of time. It's really the independent variable, and time just happens to be the independent variable in most cases. Okay, so now let's go through. What is the initial value? Well, it's the amount she purchased the car for. So we're going to replace A with 25,000 in just a second. Our rate, we can see clearly here, is 8.5. 8.5 divided by 100 is just 0.085. You can put that in the calculator, or you can just remember to move the decimal over to the left 2 units. So 0.085, this is my R. And then finally time. So where do they talk about time? The only place I can see is here where they use years. They don't give us a specific number for time. They just give us another variable. Okay, and then they say, well, keeping it for 2 years as long as it's worth more than 15,000. So think about that for a second, where that 15,000 is going to go. But next, we're going to take those numbers and insert them in for A, R, and X. So A is 25,000. 1 minus 0.085 raised to the t value is greater than y. We want this to be greater than or worth more than 15,000. So this is the inequality, but we can clean it up just a little bit by simplifying what's inside the parentheses there. 1 minus 0.085 is 0.915. So the final answer is written here in blue for the first part. The second part of the question says, is Elizabeth's car still worth more than $15,000 after 6 years? So now they give us a value for t. So we're going to figure out what is 25,000 multiplied by 0.915 after it's raised to the 6th power. Choose the calculator to type that in, 25,000. You can find this calculator for free online. Left parenthesis, 0.915, right parenthesis, raise 2 button is above the division symbol. 6. Enter. Is it worth more than 15,000 after 6 years? No. It's worth 14,671. So the answer to part 2, big fat no.